Miguel, you can take over for the the last session, which is the technical characteristics of the solution.
Right. So we've gone through the API, we've gone through a flow in terms of what the transfer looks like. Michael also took you a bit more into the specification itself. And next, just go a bit more into detail on the architecture and the individual components as well. So if you recall, we had at a high level the account lookup service, we had the quoting service, and we also had the central ledger, which was broken up into two individual components. Here is a detailed component diagram which shows the individual components of the Mojaloop switch itself. If we start at the top, we have an API gateway, and that implements a lot of the security policies for ingress and egress. At the moment, this is implemented specifically by each hub implementation, but there is in future a potential open source donation that will be provided by one of the implementers. Also, we have a core components section here, and here you can see each of the Mojaloop microservices. Each of these represents some kind of functionality. In fact, we can actually show you, for example, we have the account lookup service here, we have the quote service here, and we have all the components for the transfers. And in fact, we have two components for a Mojaloop API adapter, one for the API itself and one for handling notifications. And for the central services themselves, we have a component for handling operational admins. We have a component for handling the prepare request for the transfer. We have also the position management component, a component for handling admin operations, a component for getting or querying transfers, one for handling timeouts, and another for the full processing of the transfer. We also have the transaction component, which is mainly used for transaction API portion of the specification, basically also doing the merchant request to pay, etc. We also have components for bulk transfers, where a single request of several transfers are received by the system, and they're broken down into individual transfers themselves, processed by the transfer components, and then basically merged together for the final response of the transfer as the notifications are sent out. Below we have supporting components. So these are components that are, for example, settlements. We also have an Oracle Pathfinder component, which is available on open source. We have the scheme adapter, which you saw, which was implemented by the payee participant. We have an event processor, which is basically listening to events that are occurring within the transfers, etc., and sending notifications out as a result of those. Some of those could be, for example, the position changes, etc. We also have an email notifier here. We also have a finance portal UI where you can see some basic information about transfers and participants. We have an event stream processor, which basically takes logs, errors, and audits and tracing and ingests them into our monitoring frameworks, which I'll talk to a little bit later. We have an event sidecar, which is the component that plugs into each of these microservices and actually produces the error audits and event traces. We also have a settlement managed component, which basically handles the closing, recon reports, as well as scheduling cron jobs for basically managing those reports. And on the far left side, or on the left side, should we say, persistence, let's go here, for example, we also have some stores for example, Redis, which is used mainly for the SDK components as a caching. We also have MongoDB, which is used for the central event processor components, as well as some of the bulk transfer components as an object store. We have MySQL, which is used mainly for the central services components, the account lookup and the quotes. And we also have Kafka, which is used for the durable messaging stream component, which you saw was how the components within the transfers, the central services, then API, communicated with, between each other. We have the quality assurance section at the top here, and that's basically mainly about all the components that you would expect to handle testing. Just give me a second here, please. Just want to disable this quickly. Cool. So we have, for example, functional tests, which are implemented via Postman scripts. We have onboarding scripts as well, so you can basically onboard FSPs, participants, etc., as well as on a new installation of a switch, setting it up appropriately, creating the right accounts, etc. We also have simulator components, and these simulators can act as FSPs, or they can even act as switches, depending on how you want to do the switch, testing, etc. So it's useful for not just the hub implementers, but also useful for the FSPs or participants of the switch themselves. We have a testing toolkit, which is basically comprised of a backend and a UI component, which is basically a very nice operational testing tool. In fact, we're currently moving a lot of the Postman scripts into the self-testing toolkit, and in fact, the testing toolkit has been integrated into the Mojaloop installation itself, and it now can be used for testing brand new installations without any setup. Very easy, very simple to use, and it gives you the nice visual representation in terms of how those tests occurred. Very useful for also learning how the API works, and you'll hear more about that through the following days as well. There's a lot of, I think, updates in terms of how this is progressing. We also have some auditing and checks in terms of what licenses are being used on our dependencies within the implementation of our microservices, as well as security checks to make sure that there's no, let's say, dependencies that have any known security flaws or issues that need to be updated, etc. So we have capabilities to monitor those as well. And those have been integrated into our CI/CD pipelines. We also have a bunch of software development kits. We have the Mojaloop SDK, which is generally useful for participants. And in fact, the scheme adapter was built using that SDK. We also have an Oracle SDK, which is an accelerator. So if you want to build your own custom Oracle, this SDK can be used as a way to accelerate that. It basically makes sure that you adhere to the Oracle API specification. So it's pretty useful if you are thinking of doing that. We have an event SDK. So every single one of these, well, most of these components, should I rather say, have implemented this event SDK, and they integrate to the event sidecar here, which then produces those error audits tracing events, which is then processed by the event stream processor. That's done by the event SDK. And on the far left, we have all the operational monitoring components. So a lot of those events that are produced by the event stream, the event sidecar, and that are consumed by the event stream processor are basically sent to our open tracing and F platforms. We use APM for the open tracing, and we use F in Elasticsearch, Fluentd, and Kibana for handling the central log collection, monitoring, and tracing capabilities of the platform. We also have Prometheus, which is Prometheus and Grafana, and that basically is our real-time metric collection where we can monitor how these components are busy processing each request, as well as how many transactions per second are being processed, etc., as well as the result of some of these transfers themselves. Down below, we have our container management orchestration, where we have Helm, which we use for deployments. We have Kubernetes, which provides the actual management and orchestration of our containers. So every single one of these microservices are built using Docker and are available on Docker Hub, which is part of our integration delivery section here. And of course, one of the key reasons for that is we want to be able to deploy on any kind of infrastructure you can think of, whether it's AWS, Azure, any kind of cloud provider, or whether you're on-prem. So the fact that we're using Kubernetes ensures that we're able to be, let's say, infrastructure agnostic, and it provides that, let's say, the consistency whether we're deploying anywhere. On the left, you can see we also use Rancher. That's more in the OSS space. It just provides a management plane in terms of how we manage our Kubernetes clusters. It's also worth noting that we're not prescriptive in terms of how you deploy Mojaloop. Just because we provide Helm scripts and we provide maybe scripts and guidelines on how you can run it on Kubernetes, you don't have to do that. You are welcome to take these microservices and deploy them however you want. We obviously provide the scripts and the tools and the instructions on how we would suggest or recommend running it, of course. On the far right, continuous integration delivery. I already mentioned we have Docker Hub for the actual microservice containers. We also use Circle CI for our test, build, and deployment pipelines, as well as any pull requests are being processed, any code changes, etc., that are being requested into the main code branches are run by Circle CI through a slew of tests, building tasks, etc., to make sure they're valid, as well as the license security audit checks that we have as well. Of course, that code would only be accepted once it's being reviewed and once all those checks have been passed. We also use npm org for our, let's say, all our dependencies. All the microservices you see here are done in Node. And we also have some, let's say, common libraries that we also build and publish to the npm organization. We also have Getbooks, which we use for documentation. If you go to mojaloop.io, if you access documentation, that's documentation that we actually have a code repository for that's rendered in a nice, very friendly UI version for consumption. We also have some infrastructure as code tools that's currently being finalized at the moment, and that's hopefully will be introduced fairly shortly. And it's basically providing a full automated a tool suite to be able to deploy Mojaloop, install Kubernetes, install Helm, etc., in a productionized fashion. The next slide is just showing you how we've designed for scale. This is just a representation of the prepare leg of a transfer. Once again, on the top left, we have a payer participant and a payee participant on the right side. And that request or prepare transfer request is received by the ML API. And each of these blue boxes are those scalable microservices that you saw in the component diagram, or represents one of them at least. And here the ML API adapter receives a request. It's validating the JSON schema, and that would then be written or produced to a prepare topic. And only once that happens would an acknowledgement be sent back to the payer, where they would then wait asynchronously for that response notification to be received. And that ensures that our components are durable and can handle any kind of failure, since the prepare handler would be able to read that message, process it accordingly, save the transfer to the central ledger, save the state, as well as save a hash, which would be needed potentially for future duplicate checks. And the prepare handler would also be in charge of validating whether the participants are valid, so the payer and the payee, are they part of the switch, are they actually valid, and as well as doing a duplicate check itself to make sure that that transfer is not or has not been seen before. Then that message would go to the position handler. The position handler would then check the limits, the position, and as well as the state of the transfer, whether it can actually be changed or it's not in some kind of finalized state or maybe hasn't timed out. Assuming that it has not timed out and all those checks have been done, we would be able to reserve the funds, we would be able to commit the funds, etc. And of course, that position change would need to be persisted back to the central ledger as well as the state. And then that would finally result in the notification for the prepare leg to be sent out through the notification handler. And it's also worth mentioning that all these microservices can do concurrent processing, and that's handled by basically scaling them out as required, as per your needs. Very simple, and specifically that we're using, or at least Kubernetes provides the capability and the tools so you can easily do that. The second slide is just a fulfill leg. It's just the reverse. I'm not going to go through that in detail. The next couple of slides are just going into a bit more information in the technology stack that we've chosen. One of the key things that we've taken into consideration is all the technology choices we made have to be open source and free. And of course, most of them that we've chosen, I think in all the cases, you also have the option to be able to get some kind of enterprise support, either from the people that actually manufacture or develop the actual software or the software itself, or there's third parties that offer that capability. So that's also one of the key considerations when choosing these technologies. Here we have Kafka. Why did we choose it, or why? Basically, it allows us to publish, subscribe a stream of records It's similar to a message queue. It's not quite the same because in essence, Kafka works as a log file, actually. So, and what does this mean? It means that when a message is written to this log, it's basically a sequence of records, and it provides a way for us to order those records when we write it as such. And it also ensures that we can't change it. The very fact of a log file is you can't go and really delete things in the middle of a log file. And this capability or this aspect of Kafka ensures that immutability. And here's just an example of what it looks like. We're able to process a lot of messages via a parallel mechanism which Kafka uses called partitions. So every topic we would define however many partitions we want, and that would basically ensure that we can process those messages in a parallel fashion. And of course, these capabilities also provide us with fault tolerance, as well as durability, and a way for the history to be saved for any desired kind of period of time. You can choose how long you want that data to be there. For SQL, at least in the open source, it's worth mentioning once again, we're not prescriptive here in terms of what MySQL database you use. At least in the, let's say, the default installation of Mojaloop, we've used Bacona XtraDB. And that's mainly because it provides a cost-effective, highly available flavor of MySQL, which provides a master-master replication. And it's very much aligned to being able to deploy whether you're on-premise or whether you're on cloud, etc. It provides those capabilities to do that. We have several implementers that have not used Bacona, and they're actually using managed SQL that are provided by Azure or provided by AWS, and that's perfectly acceptable. The same with Kafka as well. You're welcome to use the one that comes installed with Mojaloop, but you can also go and use a managed version of it. I also mentioned in the Helm, I didn't go too much in detail previously, but this is quite important for us. Basically, it provides a package manager for Kubernetes. In essence, it provides the core deployment capabilities of Mojaloop. And it provides it in a way that we just are able to set up a configuration file in terms of how you want Mojaloop to be installed and configured, and it allows Helm to be able to basically deploy that in a very standard, consistent way into Kubernetes. And the nice thing, it also manages things like upgrades. You're able to just modify those configurations and then do upgrades based on those configurations. It very much simplifies things hugely. And it also supports things like rolling back updates or upgrades. So I've already mentioned Kubernetes, and I already said a lot about it, I think. But I would say the most important aspect for me is I would say Kubernetes provides, for me, infrastructure as a policy. I don't think it's really a real term per se, but I feel like it should be. And one of the benefits of Kubernetes is we're able to set up policies in terms of how we want Mojaloop to run and operate. And Kubernetes would basically make sure that it operates according to those policies. And you could have policies from from a scalability perspective. You can set policies in terms of how you want Mojaloop to scale based on CPU usage, based on network usage, etc. Or you can even create custom policies to be able to scale based on business rules if you wanted to. I'm not saying it's always an easy thing, but it's available there, and Kubernetes provides that capability. And of course, the other main aspect is we've abstracted the underlying infrastructure, whether you're on cloud, whether you're on-prem. Kubernetes is one of the key components that allows us to do that. Other nice things that it does is the durability. So it's very much a self-healing a runtime environment. And what I mean by that is when you define how you want Mojaloop to run, if you want however many pods or containers to run for a specific service, Kubernetes is always monitoring that and making sure that it's adhering to that. So if you set a certain number of scale for a specific microservice and suddenly one of them goes down, Kubernetes will then figure that out and be able to then start it up again. And the nice thing about that is it provides the high availability capability, since you can then run several processes in the background, and it also provides the load balancing capability to ensure that it's able to then redirect the load to a service that is currently functioning correctly. So it's an absolutely beautiful piece of underlying runtime infrastructure. Also, from a security perspective, it provides isolation for containers, networks, etc. And it also is a way for us to standardize how we store configuration of Mojaloop as part. So whether we're storing secrets, username, passwords, databases, or otherwise backend services, it provides a standard mechanism for us to store that in a very reliable and secure way. I mentioned Rancher. As I said, it's just basically a management plane on top of Kubernetes, and it provides the ability for us to spin up the underlying infrastructure, whether we are in Azure or Google or AWS. It provides that management console to do that. Kubernetes is not necessarily the easiest thing to use, but Rancher helps simplify some of that. For example, it also provides the capabilities to set up some of the security roles and some of the authentication, etc., in a more visual way, where traditionally you'd have to use more of a CLI to be able to do that kind of thing. I already mentioned the Grafana part of things. So basically, this is a combination of Prometheus and Grafana. So each of one of our microservices expose the individual metrics via a metric endpoint, and that is collected via Prometheus. It's scraped every few seconds. I think you can configure it actually how often you want to scrape it, but by default, I think we scrape the metrics every 15 seconds. And that information is collected, and we have a slew of dashboards that are available that you can install. And that will show you a lot of nice real-time metrics in terms of how the system is performing. And we used a lot of this for also the performance testing. So I think on Thursday, there's an update in terms of what we've done from a performance perspective. You'll see some of that in that report out in terms of what that looks like. But the key takeaway here is it's got a very low overhead, and it's a very fast, efficient way to collect a lot of data. Here's an example of some of these dashboards that we have available. It's in the Helm repository under monitoring if you want to access it. And we currently have a few of our microservices that are currently implemented with this capability. And these are the dashboards that we currently have available. So we don't have all dashboards for all the components, but we're getting them. For example, we have one for ML API adapter. We have one for each of the central ledger or central service components. We also have one for the simulators. We also have one for the backend data stores, for the messaging for Kafka, as well as the Kubernetes cluster, also for the deployments within the Kubernetes cluster. And here is actually an example of the central ledger component. Kafka, here is the lag from the actual messages that are being consumed by Kafka itself for each of the topics. And we also have, for example, the number of transactions or processes per second that are being processed by each of the microservices themselves. And here's also how long each of those are taking from a processing time perspective. So for EFK, that's a combination of Elasticsearch, Fluentd, and Kibana. So Elasticsearch is basically a well-known search and analytics engine. It provides the capabilities to filter all the logs that we have or produced by the Mojaloop microservice components. Fluentd is the component that ingests that information into Elasticsearch. It plugs into Kubernetes, and it's able to collect that information in a very much automated fashion. And Kibana is the visual representation of that information and provides the capabilities to actually set up dashboards and do the, let's say, real-time querying of that information in a visual way. Circle CI I already mentioned. That's basically where we do our automated testing, deployments, and verification, etc. I'm going to skip to this slide because I think it's a better representation of how it looks. So when anyone sets up a pull request or even potentially creates a release or pushes tags, etc., snapshots, daily builds, etc., this is kind of what you will see that occurs on Circle CI. So this is a flow here. This is actually a snapshot release, but there's actually two boxes here just to represent or show what you should expect to see. So this orange kind of box over here is for pull requests. and the bigger one is for basically tagged releases. And you can see the flow starts up with an initial setup, which basically installs some initial things that are needed for all these additional flows or tasks, and that will basically then fan out in parallel and run these checks, which include the code coverage check, for example, which then gets published also to a place that is available for anyone to go see. We also have the audit license checks, the unit tests, the functional tests themselves, the vulnerability checks to make sure there's no security issues with the dependencies, as well as integration tests if there is. And all these results are published in a place that is publicly available and accessible. Anyone can go and view these. Assuming this was a tagged release, this would continue onto the build phase where the actual artifacts are built, and we would further have image scans to check for the actual security vulnerabilities, as well as license scans to make sure we adhere to the Apache 2.0 license, or make sure that a license is compatible, pass, etc. And of course, we're making sure that the artifact that's built here, the actual container itself, passes those checks. And only once that happens, will the Docker image be published to a Docker Hub repository, which means it'll be available to everyone. And in fact, you can go to this link here and you can see all the builds that happen on a daily basis from either a tag release or a pull request, and that's all publicly accessible. Getbooks, very simply put, we write all our documentation in Markdown, and we also have a whole slew of generated content, for example, sequence diagrams, OpenAPI, Swagger docs, etc. And Getbooks basically provides the ability to represent that in a codified manner, and it's able to basically generate a nice visual way of that. And we can also use plugins to basically take some of that embedded content and create actual useful information. So for example, the sequence diagrams that we have are done in Plant UML, which is basically a codified syntax way of generating sequence diagrams themselves. And these plugins into Getbooks is able to generate those and show a visual representation of that. Something else I forgot to mention, sorry, about the Circle CI, is that when these builds and these releases occur, you can also see the results of those on the Slack organization that we have for Mojaloop. So there's an announcements channel for CI, and you're able to go there and you're able to see the results of these releases. Finally, just a quick, it's not quite really about the components and in terms of the technicality of Mojaloop, but this is just a footprint in terms of how big the community is from a code contribution perspective of Mojaloop. As you can see, there's contributors from pretty much everywhere in the world, almost every continent. Yeah, it's an amazing project. And I look forward to seeing the rest of you guys in the convening on the oncoming days. Thank you very much.
Thanks so much, Miguel. You had one question in the chat from Miller. Miguel, please expand on the use of both MySQL, /Percona, and MongoDB. What are these two very different database layers used for? Why both NoSQL and SQL-based DMBSs?
So, I mean, one of the aspects of the architectures is a microservice architecture. That means that we are able to choose different data stores for each of those microservices or areas of those microservices that are better aligned to how they use or process, let's say, the workloads. So, for example, MongoDB is used as an object store, and you can see that mainly, for example, on the bulk processing of transfers. So on the bulk side, we would receive a big message with many transfers in them. And what we would do is we would store that as an object into the MongoDB store, and we would break that up into individual transfers, which then get put into those topics that you saw in some of those diagrams. And they would be then processed individually by the existing microservice components. And then they would be basically merged again into a final response once every single one of those individual processing transfers occur. And basically that information would be correlated against the MongoDB data store or object store to be able to do that. MySQL, on the other hand, is more for the individual transfer processing. So as an individual transfer is processed by the system, the state of that transfer will be stored in MySQL, as well as the position management of each participant, etc. It's worth mentioning that the way that we persist that information in the database, we avoid as much as possible updates, and we try adhere to more of an append strategy, where the update of a transfer is more an insert of the status, as well as in some respects that's also done on the position side. So we try always insert instead of updating a single record to ensure that we don't get any table contention as much as possible. Of course, it's not always possible, but we've tried to do that as much as possible. And I think one of the nice things about that is that also gives us a history of let's say, the transfer itself. So inevitably, because we're doing the insert pattern, that means that for a transfer, you'll be able to see all the status changes of that transfer in the database as it flows through the system, which is pretty nice and pretty handy.
Awesome. Thanks so much, Miguel. I've dropped a link in the chat in case anybody has any more questions, and you can get both the slide decks and answers to any of the questions in there. This brings us to the end of our first day. Thank you everybody for joining us.